For thousands of years, humanity thrived in a stable climate. But that balance is now unraveling. Greenhouse gas emissions are warming our world at a record pace, leading to melting ice, rising seas, and extreme weather. We've pushed Earth's systems out of equilibrium, and now some ask, can we engineer the planet back to health? Geoengineering is not about small fixes. It's about large-scale interventions in Earth's natural systems to counteract climate change. Imagine adjusting the planet's thermostat or performing planetary surgery. Ideas born from both desperation and technological optimism. As temperatures break records, the urgency grows. While cutting emissions is essential, some see geoengineering as a backup plan, a way to buy time or soften the worst impacts. But this path is risky. Manipulating Earth's complex systems could have unforeseen, even catastrophic consequences. The Earth isn't a simple machine. Our understanding is incomplete. Intervening at this scale raises profound ethical questions. Who controls these technologies? What are the risks? And what does it mean for our relationship with nature? The debate is no longer science fiction. It's happening now, in labs and governments worldwide. Geoengineering could be planetary medicine, but it's also a leap into the unknown. The dilemma: do we dare to experiment with the only home we have? The stakes could not be higher. Geoengineering proposals fall into two main camps: carbon dioxide removal, CDR, and solar radiation management, SRM. CDR tackles the root problem, removing excess CO2 from the air like cleaning up a spill. The goal: gradually restore atmospheric balance and cool the planet over time. SRM, by contrast, aims to reflect sunlight away from Earth, treating the symptom, warming, rather than the cause. Think of it as putting up a planetary sunshade for rapid, temporary cooling. CDR is restorative, but slow and expensive. SRM is fast and potentially cheaper, but far riskier. The key difference: CDR removes the problem, SRM masks it. If SRM stops, the hidden warming returns with a vengeance. Both approaches come with technological, ethical, and environmental challenges. CDR is seen as safer but requires massive scale. SRM is radical, interfering directly with weather and seasons. The choice, or whether to pursue either, may be one of humanity's most consequential decisions. Each path offers hope, but also profound uncertainty. The world must weigh these options carefully. Solar radiation management is the most dramatic geoengineering idea: cool the planet by reducing sunlight. Nature has shown this is possible. Mount Pinatubo's 1991 eruption cooled Earth by half a degree for over a year. SRM aims to mimic this with stratospheric aerosol injection. Aircraft or balloons would release reflective particles like sulfur dioxide into the upper atmosphere. These particles scatter sunlight, cooling the planet quickly but temporarily. Another idea, marine cloud brightening, uses ships to spray sea salt, making clouds whiter and more reflective. Both methods could lower temperatures fast, but neither addresses the root cause, CO2. The risks are huge. Altering sunlight could disrupt weather patterns, shift monsoons, and threaten food supplies for billions. The greatest danger is termination shock. If SRM stops suddenly, rapid catastrophic warming could follow. SRM would require commitment for centuries with no room for error. The prospect of dimming the sun is unsettling, and the consequences are largely unknown. SRM is a potential emergency brake, but one with enormous risks. The world must ask, is this a risk worth taking? Carbon dioxide removal is about tackling the source, pulling CO2 out of the air and locking it away. Nature's solution is simple: trees. Reforestation and restoring coastal ecosystems like mangroves absorb carbon and boost biodiversity. High-tech options include direct air capture, machines that filter CO2 from the air and store it underground. These technologies are promising but currently expensive and energy-intensive. Another idea: enhanced rock weathering, spreading ground-up rock on fields to chemically bind CO2 and store it in the oceans. All CDR methods face challenges of scale, cost, and potential ecological impacts. Unlike SRM, CDR is slow but addresses the root problem. The task is monumental. Removing billions of tons of carbon will take decades. Still, CDR offers a path to true restoration, not just a temporary fix. The question: can we scale these solutions fast enough to matter? Turning geoengineering from theory to practice has proven difficult, with many experiments facing public resistance. Harvard's SCOPEX project, aiming to test stratospheric aerosols, was cancelled after fierce opposition from environmental groups and indigenous communities. Critics feared even small tests would normalize risky technologies without proper debate or oversight. A marine cloud brightening experiment in California was also shut down over health and transparency concerns. Yet some restorative projects have moved forward, like thickening Arctic sea ice by pumping seawater onto it, which showed promising results. These experiments highlight the tension between scientific curiosity and societal caution. Public trust, transparency, and ethical debate are crucial for any future research. The fate of these projects shows that geoengineering is not just a technical challenge but a social one. Without broad support, even the smallest tests may never leave the lab. The world remains wary of planetary-scale experiments. The debate is far from settled. Supporters see geoengineering as a last resort, a way to prevent climate catastrophe and buy time to decarbonize. Technologies like SRM could, in theory, avert tipping points like ice sheet collapse or rainforest die-off. Proponents argue it's a moral imperative to explore every option to reduce suffering from heat waves, droughts, and floods. But critics warn of unintended consequences, disrupting monsoons, triggering droughts, or causing new disasters. The risk of termination shock looms. If SRM stops, rapid warming could devastate ecosystems and societies. Geoengineering could trade one crisis for another, with effects we can't predict or control. The debate is fierce because the stakes are existential. Are we risking even greater harm in our attempt to fix the climate? The choice is between uncertain hope and the fear of irreversible mistakes. Geoengineering is a gamble with the future of the planet. The world must decide if it's a risk worth taking. Geoengineering raises deep ethical questions, starting with moral hazard. The fear, if a technological fix exists, will we stop cutting emissions and let the root problem fester? There's also the danger of hubris, believing we can safely manage Earth's climate, despite a history of unintended consequences. From CFCs to fossil fuels, our interventions have often backfired. Geoengineering could be the ultimate act of arrogance, with risks we can't foresee. Intergenerational justice is at stake. Future generations would inherit the burden of maintaining these systems or face disaster if they fail. Is it right to impose such obligations on those yet unborn? An engineered planet would change our relationship with nature. Skies could turn paler, sunsets shift, and the world would feel less wild, more artificial. For many, this represents a profound loss, a step away from living with nature, toward living inside a machine. The ethical dilemmas are as daunting as the technical ones. Before acting, we must ask, do we have the wisdom to wield such power? If geoengineering ever becomes a reality, who decides how it's used? There's no global authority to regulate these powerful technologies. A single nation or corporation could act unilaterally, affecting the whole planet and risking conflict. Imagine one country cooling itself, causing drought in another. Could this spark international disputes or even war? The technology could become a weapon, and the risks and benefits would be unevenly distributed. Private companies are already experimenting, raising concerns about profit-driven deployment without oversight. A global framework, likely under the UN, would be essential for legitimacy, transparency, and fairness. Building such governance is a monumental challenge, perhaps harder than the technology itself. Without it, geoengineering could lead to chaos and conflict. The question of control is as urgent as the science. Who holds the thermostat may shape the fate of the world. Humanity stands at a crossroads. Climate change demands action, and geoengineering offers a tempting, risky set of tools. The allure of a quick fix is strong, especially as disasters mount. But manipulating the planet's climate is an experiment with only one subject: Earth. The risks, droughts, ecosystem collapse, technological dependency are enormous. The real danger is moral hazard, using geoengineering as an excuse to avoid cutting emissions. The fundamental question isn't can we, but should we? The alternative is not inaction, but restoration, ending fossil fuel use, investing in renewables, and protecting nature. This path is harder, but safer, and more just. Our choice reflects two visions: control through technology or wisdom and balance with nature. The greatest challenge may be to our values, not our science. Before we try to engineer our home, perhaps we should focus on healing it. The future depends on the path we choose.